Welcome to my video of cognitive theories and how they influence the instruction we use in our courses. My name is Kim and thank you for joining me. So let's begin with a look at these theories. Cognitive load theory focuses on the amount of mental effort used in the acquisition of information, according to Poss and Sweller 2014. This theory has two components. The first is cognitive architecture. This is composed of the working memory, the schemas, and the long-term memory. The working memory decides whether or not the information is important enough to hang on to. If the information is deemed important, then the schemas come into play to organize the information by adding this information to existing schemas or creating new ones. Finally, information will be put into the long-term memory for permanent storage and future reference. However, it should be noted that the working memory has limited capacity with a retention of 5 to 9 pieces of information for about 20 seconds. The second component is the cognitive load conditions. There are 3 different ones associated with this theory. Intrinsic cognitive load, which occurs due to the complexity of the learning material itself. So low cognitive load happens when the material is simple, high when the material is considered difficult. Extraneous cognitive load occurs due to the way the material is presented. Low extraneous load occurs when the materials are presented in a pristine screen and is very clear. A high load occurs when the materials are blurry, hard to see, or smeared. Then the cognitive load is high. Germane cognitive load occurs due to the learning process itself. When more of the working memory resources are used processing with intrinsic cognitive load, and then fewer are used with extrinsic cognitive load, the more effective the instruction will be. This will lead to high germane cognitive load. The second theory we need to speak about is the cognitive theory of multimedia learning. This theory examines learning and understanding through the use of multimedia, pictures and words, based on how people process this information. This is according to Mayer 2014. So the model consists of multimedia types, words and pictures, sensory memories, how we perceive the multimedia, our ears and our eyes, the cognitive architecture components we just discussed, working memory, schema, and long-term memory. There are 3 assumptions associated with this theory. The first assumption is based on dual channels. So this means that we process information through separate channels, one for the eyes and one for the ears. The second is limited capacity, and as we already mentioned, the working memory is limited. It can retain about 5 to 9 pieces of information for about 20 seconds. Active processing refers to the cognitively active learners who select and organize information within the working memory and integrate this information with existing schemas or building new ones. There are 3 cognitive processes in this theory. Each one is comparable to the cognitive load conditions from the cognitive load theory. So that was just discussed. So the extraneous processing in this theory is comparable to the extraneous cognitive load. Essential processing is comparable to the intrinsic cognitive load. The generative processing is comparable to the germane cognitive load. How are these 2 theories related? The cognitive theory of multimedia learning builds on the cognitive load theory by expanding the theory by adding the sensory memory, which is the bringing in of new information through our ears and through our eyes. Therefore, it is clear from our discussion that in our instruction, we would need to reduce extraneous cognitive overload. I would like to discuss principles that would achieve this. They are coherence, signaling, and spatial contiguity, according to Meyer and Fluella, 2014. Coherence principle states, individuals learn more deeply from a multimedia message when the extraneous material is excluded. By excluding this material, non-relevant pictures, blurry words, glare on the screen, the learner's attention can be focused on the material itself. Schemas can be expanded and permanent learning can occur. It should be noted that we need to use the appropriate intrinsic cognitive load based on our learners. This would result in maximizing meaningful learning. So here's an example. This is a violation of the coherence principle. The font is too hard to read, there are too many pictures. This requires extrinsic processing resources to scan and make sense of the images and the words. So the intrinsic processing is stifled. To promote more meaningful learning, we could reformat this slide and eliminate the extraneous factors, drawing the attention to the learning material. And here's what the new slide would look like. Another principle is signaling, which states that individuals learn more intensely from multimedia messages when cues, such as arrows or underlines, showcase the necessary information or knowledge. Signaling principle directs the learner's attention to the essential information that's needed to be integrated into the existing schemas and then into the long-term memory. Signaling decreases the extraneous load. So here we have a map of the United States, and we want the learner's focus on New York State. So we can use the arrows to draw the attention here. The last principle is spatial contiguity. This principle states that individuals learn more deeply when words and pictures are near each other on the screen or page. The use of spatial contiguity directs the learner's attention towards the essential information in one place and then decreases the extraneous cognitive load because you don't have to scan between pages or back and forth or spaces looking between words and pictures. This makes the processing resources directed towards the essential material, resulting in the working memory doing its job and thus leading to meaningful learning results. So here's an example. Here is a world map with particular continents highlighted through the use of pictures and words together in proximities. This makes it much easier to scan and retain the essential information. Extraneous cognitive load is reduced. Meaningful learning will result since the working memory can identify what is important and begin the organizing and integration with schemas and the long-term memory. There is a concept of refutation, according to Tippett, 2010, that can help to reduce cognitive overload since accurate knowledge can be obtained, thus replacing old misconceptions. In the use of refutation text, there are three components: misconception, refutation cue, and refutation with current accepted explanation. So let's look at an example of this. So the first line here says companies should rely exclusively on the use of online recruitment. This is the misconception. This statement is not correct. This is the refutation cue. Not everyone in the workforce has computer access, appropriate computer skills to apply online, and not all jobs require computer skills. This would be the refutation with currently accepted explanation. So this is helpful once again to replace misconceptions with not only new information but accurate. So here is a list of the references that were used in the creation of this video in case you would like to have further reading. Lastly, I would like to thank you for joining me. I hope you have learned some important tips to consider when designing your courses to reduce cognitive overload. Thank you.